Okay, right. So let's conclude this lecture by looking at the applications of solvent extraction in mineral processing flow. Right. So here we see flow sheet for hydrometallurgical processing of chalcocite. You can see here that is pressure leaching here. Then we can see here there is extraction, and here is electrowinning. So we can safely say that the first unit of hydrometallurgy, the second unit of hydrometallurgy, then the third unit of hydrometallurgy, as you can see here, you're leaching first, purification, and then lastly recovery here. So we can see on your second stage here that there is your solvent extraction. Actually, there is a primary and a secondary solvent extraction. Then we talked of scrubbing in one of the slides, and there is a scrubbing circuit for your organic. Okay, so let's look at this circuit now using some values. Okay, so this is a circuit again for your copper. So we have got your extracting, and your stripping cells here. Okay, so you can see from your pregnant leach solution, it's a solution which is coming in the extraction step at 1.6 kilograms of copper per cubic meter. And then you can see here that when you finished your extraction and your stripping, it's actually 45 kilograms of copper per cubic meter. So now this is now a rich electrolyte that can be taken now for electrowinning process. Okay, right. And then on the left side here, you've got your raffinate or your lean solution, which are only 0.3 kilograms of copper. So you can recycle this back for your leaching process. Okay, all right. Right, so you understand what's happening here, right? In terms of the equations, we've got your organic extractant here, and then the aqueous pregnant leach solution, 1 to 6, and then you've got your raffinate lean solution on the right of the equation, 0.3, and then the organic is now loaded with your copper. Okay. Then for the strip, which is the reverse reaction, you're saying this high acid copper depleted electrolyte, about 35 kilograms of copper. Then we've got your loaded organic extractant. And then when the reaction goes forward, you can see that you now have got your depleted organic extractant. And then you've got now this rich electrolyte that is now being taken for electrowinning process. Okay, right. So your RH, as you can see, there is an RH here, and there is also an RH here, which is your organic extractant. They are, in this case, for copper, they use an aldoxime or a catoxime extractant. Okay, right. So this is these are your oximes. You can see here in their single state. Then here they have actually extracted the copper. Okay. Right. So oximes are quite thick and viscous on their own. Hence, they need to be diluted. We talked about this in one of the slides. They're actually diluted 8 to 20 times using paraffin or kerosene. That's before you use. So as a metallurgist or as a process engineer, process metallurgist, what problems do you foresee if you don't dilute the enzymes? Just for you to brainstorm. If we are saying that it is quite thick and quite viscous, so what problems do you foresee if you do not conduct the process of dilution here, as we have depicted? Okay, so kindly brainstorm on that. Okay, so let's go back to our process flow sheet. Now we introduce in brackets the concentration of copper in kilograms per cubic meter. So here 1.1, 4.2, 2.3, here there's 3, and there's 45, and there's 35. Okay, this is the concentration of copper in this circuit. Okay, right. So first of all, you'll be required to calculate the strength of this lixiviant, the strength of your solvent that is extract a specific amount of copper. Okay, specific amount of copper. That's what you first calculate. So you're given the information that the organic extraction can extract up to 0.25 kilograms of copper per cubic meter of organic phase per percent volume of your extractant in organic phase. So using this mass balance here, you can be able to calculate the strength um, of your solvent extractant here using this equation. Okay. So kindly find the missing figure here using this balance. And you can also be next needed to calculate the rate of extraction into the organic phase. Okay, so I've given you the formula for calculating the rate of extraction. I want you to find out the extraction rate. Okay, this is the information that you've given before. So take note and use that information. Okay, right. So when you finish that, I would like you to do your assignment number 3. Okay, I would like you to research on the other purification or recovery techniques used in hydrometallurgy. I would like you to outline the process description, merits and demerits, and also just provide a case study of one industrial application of the recovery technique on this the process parameters. So you're going to address precipitation, ion exchange, then carbon absorption and resin absorption. Okay, so that's your assignment number 3. Right, so just in brief, as we conclude, so we said leaching to purification to recovery. Those are the 3 unit processes in hydro. Okay. Then for the recovery, now there are processes such as crystallization, precipitation, electrowinning, and hydrogen reduction. Okay, those are some of the recovery. So this is crystallization. Well, it's a you can go over this one. And there's hydrogen reduction. You can also go and find more. Right. So your assignment number 4, which is due in 2 weeks' time from today. Okay, that's your assignment number 4, due in 2 weeks' time from today. I'd like you to identify a publication in a reputable journal that covers hydrometallurgical aspects of your leaching, purification, and recovery, and then conduct a critical review of this paper, just 5 pages maximum, typed. Then I'd like you to give a brief understanding of what processes they use, the equipment that they use, the merits and the demerits of their processes. Okay. Then because it's a critical review, I want you to tell us what the paper lacks or what improvements you could suggest. Okay. So I've laid down here some tips where you find a journal paper, the title, review of, and then you see how a review is done. Then you can also research on Google how a critical review is done, and then you follow the steps that are involved. Okay.